Moynas learning.
Intro to machines.
Khushi, what are you doing? You're turning as red as a tomato.
This box is too heavy. I need to move it out of the way to clear the path.
You don't need to be a giant, Khushi. You just need a machine.
A machine? But Buddy Bot, machines are big things, with engines and loud noises, right?
Not always. A machine is not just something with wires and batteries. A machine is anything that makes our work easier. Even a spoon or a pair of scissors is a machine.
Let's learn how we can do big tasks without having giant muscles.
Khushi, we can lift this easily. Slide one end of that sturdy stick deep under the edge of the box. Now slide this small rock right underneath the stick, close to the box.
Oh, I get it. It's just like setting up a seesaw.
Exactly. Now, push straight down on the long end of the stick.
Wow. It felt like the box became light as a feather.
That's physics! This is a lever.
What exactly is a lever, Buddy Bot?
A lever is just a long, strong stick that pivots on a fixed point. When you push on one part of the stick, it boosts your strength to move something heavy at the other end. It makes hard work feel easy. The concept of a lever is based on three things: fulcrum, load, and effort. Fulcrum. The point where the rod touches the support is fixed and does not move. This resting point is called the fulcrum.
Fulcrum, a fixed point around which a lever moves.
Load. The heavy object that we want to move is load. It is the box or a stone.
Load, the object to be moved.
And effort. The force we apply to the rod is effort.
Effort, the force applied to the lever.
So the support is the fulcrum, the box is the load, and my push is the efforts.
Exactly!
Wait, Nikhil, does the fulcrum always have to be in the middle like the rock under the stick?
Great question, Khushi. Depending on where the fulcrum, load, and effort are placed, we have three classes of levers.
Look at the seesaw. This is a class 1 lever. In this class, the fulcrum is in the middle. One side has the load, and the other side has the effort. Now look at the scissors the gardener is using. Scissors are also a class 1 lever. The screw in the middle acts as the fulcrum. The handles are where we apply the effort. And the blades cutting the plant are the load.
A class 1 lever is special because it can make work easier. Now here's a secret. Can you guess how we can lift the same heavy box or stone with less effort?
We move the fulcrum closer to the heavy box. When the fulcrum moves closer to the load, lifting becomes much easier.
Why does this happen?
The distance between the load and the fulcrum becomes smaller. This shorter side is called the load arm. At the same time, the distance between effort and the fulcrum becomes bigger. This longer side is called the effort arm. So one side becomes shorter and the other side becomes longer because the fulcrum has shifted position. A longer effort arm gives your push more turning power. That's why lifting the heavy box becomes much easier.
Just like on a seesaw. If you sit farther from the center, you get more power to lift the other side. A Class 1 lever changes the direction of force. If you push down on one side, the other side goes up.
Wow! Opening this bottle cap is so easy with this tool. Is a bottle opener a lever too?
Yes, that is a Class 2 lever.
In Class 2 lever, the load is in the middle. Example Nutcracker. Bottle opener. In Nutcracker, the hinge at the end is the fulcrum. Nut in the middle is the load. And your hands on the handles are the effort. In bottle opener, the tip resting on the cap is the fulcrums. The cap being lifted is the load. And you pulling the handle is the effort.
A Class 2 lever makes heavy work easier. It helps us use a small effort to lift a bigger load.
So, if the fulcrum and the load have had their turns in the middle, that means, for the last one, the effort must be in the middle.
You're a genius, Khushi. That is a Class 3 lever.
In Class 3 lever, the effort is in the middle. Example, ice tongs. Fishing rod. Ice tongs. The hinge at the top is the fulcrum. You squeeze the middle, that is effort. And the ice at the bottom is the load. Fishing rod. Your hand holding the base is the fulcrum. The hand pulling the middle is the effort. And the fish is the load.
A Class 3 lever helps us move things faster and farther. But we have to use more effort.
Because it gives us precision. It's useful for delicate work. For example, a surgeon uses tweezers to perform very careful operations. It helps us move things exactly where we want them.
Wow! Levers are everywhere, from seesaws to surgery. Lever. Class 1, fulcrum in middle. Seesaw, scissors. Class 2, load in middle. Nutcracker, bottle opener. Class 3, effort in middle. Tongs, fishing rod. Quiz time! Can you guess which class of lever each of these belongs to? Balance scale. Class 1 lever. Load. Fulcrum. Effort. Garlic crusher. Class 2 lever. Load. Fulcrum. Effort. Wheelbarrow. Class 2 lever. Load. Fulcrum. Effort. Dumbbell. Class 3 lever. Load. Fulcrum. Effort. Shovel. Class 3 lever. Load. Fulcrum. Effort. Hand pump. Class 1 lever. Load. Fulcrum. Effort. Wow! We discovered one simple machine could have so many different forms.
Yup, this is only the beginning. There are still more amazing simple machines waiting to be explored.
In our next adventure, we'll discover machines that help us lift flags, roll faster, climb slopes, split wood, and hold giant structures together.
See you in Part 2, Science Experts.